In this video, I'll be going over how to georeference an image using Geographic Imager. To start, we're going to open the NAOC 4th edition Vegetation Regions JPEG. Go to File, Open, and select a file. In the Geographic Imager sidebar, notice that there is no reference file and no coordinate system for this image. We know the map is from the 4th edition of the National Atlas of Canada, which was published in 1974, which is before either the NAD83 or WGS84 datums that are commonly used today were developed. Because of this, we probably want to use the NAD27 datum, which is the predecessor of NAD83. We're going to examine the map to see if we can find any relevant information about the map projection. In the bottom left, we can see that the map was created using a Lambert conformal conic projection with standard parallels at 49 and 77 degrees north. We also have a graticule grid on the map which provides convenient points with known coordinates that will let us georeference the map accurately. Open the Georeference tool in the Geographic Imager panel. The first icon on the left side of the window is the Add Points tool, which we can use to create control points on an image. The Select tool lets you select control points, and you can also pan and zoom on the image in the Preview window. The Validate tool allows you to validate points by comparing to a web map. We'll be going over this in more detail later on. Zoom into the intersection of 60 degrees lat and 60 degrees long on the map and add a control point. You can see here that the point appears in the list of control points with image coordinates as px and py, but has no world coordinates. Double-click on the dashed lines under Coordinate System to edit the world location for this point. Click on None and change the coordinate system to NAD27, as we're assuming that the latitudes and longitudes on the map were made using this datum. Leave the input format as decimal degrees and enter 60 for lat and minus 60 for long, since these are longitude values to the west of the prime meridian. Repeat the previous steps for the next intersection of 60 lat and minus 70 long. We could repeat this process until we have control points along the whole grid. However, in order to save time, we will import a pre-made list of control points in a moment. Entering known coordinates isn't the only way to assign world coordinates to an image location. You can also assign coordinates to locations using stable map features like borders. Zoom into the US-Canada border in Lake Ontario and click to add a point at the corner. Click on Assign World Coordinates Online and zoom to the same location on the web map. Then click on the map to assign that location to the point and click OK. Because we use the web map, this point will use WGS84 as its coordinate system. Finally, we can import all our other points for the grid locations. Click on Import Additional Control Points and navigate to the NAOC Vegetation Regions Control Points CSV file and import it. Now that we've created all our control points, we can specify the destination coordinate system. At the bottom right of the window, click Specify next to Image Coordinate System and click No Coordinate System Specified. Recall that we know the map is projected in Lambert conformal conic projection with standard parallels at 49 and 77 degrees latitude, and that based on its age we can assume that it uses the NAD27 datum. Search for Canada Lambert to find possible projections for our needs. Nothing comes up that uses NAD27, so let's take a look at the NAD83 Statistics Canada Lambert. Click on the blue information icon to see the projection details. We can see that the projection parameters seem to match our map, but the geodetic datum is NAD83 instead of NAD27. Since we're working at a national scale, we could probably safely use this projection and ignore the difference between these similar datum, or we can also easily create a customized version of this projection. Close the info window and click on the Copy Object icon to create a copy of the NAD83 Statistics Canada Lambert projection. Rename the new projection to NAD27 Canada Lambert and then click on the Definition tab. Click on the three dots next to the geodetic field and select NAD27. Leave the other parameters as they are. Click OK and choose to continue without saving the custom projection, and click OK again to continue. We can look at the errors for the control points to see how good our georeferencing is. If we believe there was some distortion in the map image, we could choose to rectify it to try and improve it. Check the Rectify box and select Proceed to rectify the image. In the Rectify drop-down menu, we can see that there are several options. Error values get smaller as the amount of points used to rectify the image increase. We won't be rectifying our image, however, so we can uncheck the Rectify box. Finally, we can validate the georeferencing in a few different ways. To start, we'll validate some points by comparing them to a web map. Using the Validate tool, select a few points that will also be recognizable on a web map and see whether the location on the web map matches the location selected in the image. We can also import other data to check our alignment. Close the Georeference tool and go to File, Import, GI, Lines and Areas Import to import the Canada shapefile. In the Paths panel, select the Canada path and click on the Load Path as Selection icon at the bottom of the panel to get a better view. Zoom and pan around the map to see how the path aligns with the image. We can see that the alignment of our georeferenced image is fairly close to that of the Canada shapefile we imported. And that is how we georeference an image in Geographic Imager.